Welcome to this video. We're going to learn the work-kinetic energy theorem. This theorem talks about something, it refers to a body, but in physics a body is just another term for an object. The theorem states the net work on a body equals the body's change in kinetic energy. Net work means we're talking about the work done by the net force. The most common mistake is to forget the word change. Let's write this as an equation. This theorem, you would write like this: W net is equal to delta KE, the change in kinetic energy. Every change is final minus initial. So the right side could be written like so: final kinetic energy minus initial kinetic energy. The formula for kinetic energy is 1/2 times the mass times the speed squared. So in place of KE final, we could write 1/2 mv final squared, and instead of KE initial, we could write 1/2 mass times the speed initial squared. And in this case, W net is the net force times the distance times the cosine of the angle between the net force and the distance. And of course, in this equation, because it's a work equation, net force really just means the magnitude of the net force. But we are not going to use this equation at the bottom. I just wanted you to see that this is what we're referring to when we say W net. Or in other words, W net is the work done by the net force. Okay, let's draw some conclusions. Here's the formula. Whenever the net work, the left side, is positive, that means the object sped up, or the speed increased. Why is that true? To get a positive W net, this KE final must be bigger than what you subtract, KE initial. So you must have something like 6 minus 5, a bigger number minus a smaller, to get positive net work. If the net work on a body is negative, that means you're subtracting a bigger number, so KE initial is bigger, and then you slow down to get a lower KE final. And if an object's speed doesn't change over some interval, if final and initial kinetic energy are equal, then the net work on the object is 0, because you're subtracting something like 5 minus 5, because the speed doesn't change. All right, let's do two quick problems. A 4,500 kilogram truck increases speed from 3 meters per second to 8 meters per second. What is the net work done on the truck during this time? You use the equation, final kinetic energy minus initial is equal to the W net, the net work. The final kinetic energy is 1/2 mv final squared, likewise for initial. So you plug in, first I'm going to factor out 1/2 times m. I'm going to factor it out of each of these terms, and I get this. And then you plug in values. The mass is 4,500. The final speed is bigger, it's 8. The initial speed is smaller, 3. So you can see that W net will be positive because the object sped up. And it comes to this value. Okay, here's another example. A 5 kilogram ball is thrown upward into the air at 11 meters per second. What net work has been done on the ball when the ball reaches its maximum height? Now at the maximum height, what happens to the ball? It stops. So we use this equation. We're going to plug in 1/2 mv squared, both for the for the final KE and the initial KE. I factor out 1/2 times m again, and then I plug in values. The mass is 5. At the top, the final speed is 0. The initial speed it was thrown with is 11. Now notice, because the final is smaller than the initial, because you slow down, the W net will come out negative, and that's the value you get.